Deep beneath our feet, buried in rock layers 65 million years old, scientists have discovered something that should not exist. Microscopic spheres of rare metals scattered across the globe, in a pattern that mirrors exactly what we see from modern nuclear testing. But these spheres predate human civilization by an impossible margin. We have always believed we were the first species to split atoms, to melt metals, to burn fossil fuels and change our planet's atmosphere. But what if we were wrong? What if Earth has hosted advanced civilizations before and geological time simply erased every trace of their existence? Welcome back. Settle in, slow your breathing, and let your mind open. It's time to relax and relearn what you thought you already knew. In 1980, geologist Walter Alvarez was examining rock layers in the hills of Gubbio, Italy, when he found something extraordinary. A thin clay band marking the boundary between the Cretaceous and Paleogene periods contained levels of iridium 30 times higher than normal. This rare metal is abundant in asteroids, but virtually absent from Earth's crust. The iridium spike became proof of the asteroid impact that killed the dinosaurs 65 million years ago. That single catastrophic event left a signature so clear it can be read in rocks across the entire planet. The discovery revolutionized our understanding of mass extinctions. But what fascinated scientists most was how clearly this single day of violence could be preserved across such vast stretches of time. Earth keeps records, not vague traces, but precise, readable signatures of events that shaped our world, chemical markers that persist through millions of years of geological change, isotope ratios that remain constant even as mountains rise and erode around them. This revelation sparked a troubling question. If one asteroid impact could leave such obvious traces after 65 million years, what signatures would an advanced technological civilization leave behind? And more importantly, would we even recognize them? Would we know what to look for in rocks hundreds of millions of years old? Would we be able to distinguish between natural geological processes and the chemical fingerprints of ancient industries? The Silurian hypothesis emerged from this thinking. Named after an ancient species from Doctor Who, reptilian beings who evolved intelligence long before humans, built a civilization, then vanished. This scientific theory asks whether industrial civilizations could have existed on Earth millions of years before us, leaving behind traces so subtle or so transformed by geological time that we simply haven't recognized them yet. The hypothesis doesn't claim previous civilizations definitely existed. It asks a more fundamental question. If they had existed, what evidence would remain? And having answered that question, it asks, do we see such evidence when we examine Earth's geological record? Consider the scale of deep time. If human industrial civilization lasted 10,000 years and then vanished, that period would represent just 2 10,000ths of 1% of Earth's 4.5 billion year history. Finding evidence of such a brief period would be like searching for a single page in a library containing 4 million books. The books aren't organized, many pages are missing, some are water damaged or burned, others have been torn apart and scattered. Yet despite these challenges, evidence should exist. Every industrial civilization must consume energy on massive scales to power factories, transportation, heating, and all the systems that support technological society. This energy consumption inevitably alters atmospheric chemistry in detectable ways. Every civilization must produce waste products that persist far longer than buildings or machines. Plastics that take hundreds of thousands of years to fully degrade. Radioactive isotopes that remain detectable for millions of years, chemical compounds that don't occur in nature and can only be produced through industrial processes. These signatures become part of Earth's permanent geological record, preserved in rock layers that form as sediments accumulate at the bottom of oceans and lakes, preserved in ice cores that trap atmospheric samples in annual layers, preserved in mineral deposits that grow slowly over millions of years. The geological record is Earth's memory, and it remembers everything that leaves a chemical trace. The challenge lies in recognizing these signatures. We know what modern industrial activity looks like because we're creating it right now. We pump carbon dioxide into the atmosphere at rates measured in billions of tons per year, altering the carbon isotope ratios of atmospheric CO2 in ways that will be detectable millions of years from now. We scatter plastic particles across every ocean, every continent, every remote island, creating a global marker layer that future geologists will easily identify. We produce radioactive isotopes through nuclear weapons testing and power generation that will persist for tens of thousands of years, marking our presence in ways that cannot be erased. Future geologists examining Earth millions of years from now would easily identify our impact. They'd see sharp boundaries in the geological record where carbon isotope ratios suddenly shift in patterns that don't match natural processes, where plastic particles appear in enormous quantities in sediment layers that previously contained none, where radioactive elements that don't occur naturally show up in concentrated bands marking the brief period when humans split atoms and tested nuclear weapons. They might call it the Anthropocene, the age when humans began reshaping the planet through industrial activity. The chemical signatures would be unmistakable. The timing would be clear. The evidence would persist for as long as Earth maintains geological processes that preserve sedimentary records. But what if previous civilizations used different technologies? What if they harnessed energy sources we haven't discovered, or at least haven't exploited on industrial scales? What if they developed materials that decay differently than our plastics and concrete, leaving behind traces we wouldn't immediately recognize as artificial? What if they built their industries using principles we don't understand, creating chemical signatures we've been observing but misinterpreting as natural phenomena? Their signatures might be hiding in plain sight, dismissed as geological curiosities or attributed to natural processes by scientists who assume we were first. After all, if you don't think to look for evidence of ancient civilizations, you might not recognize it even when it's staring you in the face. The iridium layer proves that Earth preserves evidence of dramatic events across vast spans of time. If the planet can maintain a record of a single day when an asteroid struck, a day 65 million years ago, it should also preserve traces of civilizations that might have thrived for thousands or even millions of years before vanishing into deep time. Scientists began examining the geological record with new eyes, searching for patterns that might indicate ancient industrial activity, chemical anomalies that don't quite fit natural processes, despite decades of trying to explain them through conventional geology. Isotope ratios that mirror what we'd expect from technological civilizations rather than natural, geological or biological processes. Mineral formations with properties that seem engineered rather than geological. Distribution patterns that suggest coordination and purpose rather than random natural occurrence. What they discovered challenges our most fundamental assumptions about life on Earth. The evidence starts with mysteries buried in the fossil record itself, gaps so enormous and so systematic that they demand explanation beyond simple preservation bias. Earth's fossil record should tell a complete story of life on our planet, a continuous narrative stretching from the first single-celled organisms billions of years ago to the bewildering diversity of modern species. Instead, it reads like a book with most of its pages ripped out, leaving behind fragments that hint at chapters we cannot read. Scattered paragraphs from different stories, incomplete sentences that start mid-thought and end abruptly. Paleontologists call these missing sections gaps, but that word fails to capture their staggering magnitude. We're not talking about minor holes in an otherwise complete record. We're talking about enormous voids where entire evolutionary transitions should be documented but simply aren't there. 540 million years ago, something happened that scientists call the Cambrian explosion. In a geological instant, perhaps 10 million years, maybe less, which sounds like a long time, but represents barely a blink in Earth's 4.5 billion year history. Complex life forms appeared suddenly in the fossil record as if someone had flipped a switch. Before this event, we find mostly simple single-celled organisms drifting in ancient seas, bacterial mats, algae, primitive creatures without complex body plans. Then suddenly the oceans teem with creatures possessing eyes that can focus images, shells that protect soft bodies, segmented bodies with specialized appendages, sophisticated nervous systems capable of coordinated behavior and complex responses to environmental stimuli. This transition should have taken hundreds of millions of years of gradual evolution, natural selection working slowly, generation by generation, building complexity through countless small modifications, random mutations, occasionally producing beneficial traits, selective pressures gradually favoring organisms with slightly better adaptations. The patient, methodical work of evolution sculpting life through deep time. Instead, it appears to have happened almost instantaneously in geological terms, compressed into a time frame that makes evolutionary biologists deeply uncomfortable. The rocks show a sudden transition. The fossils appear fully formed. The evolutionary history that should connect simple organisms to complex ones is simply missing. The fossil record offers no explanation for this dramatic leap in complexity. No intermediate forms showing the gradual development of eyes from light-sensitive cells through increasingly sophisticated optical systems. No evolutionary pathway documenting how simple nerve clusters became complex brains capable of processing sensory information and coordinating body movements. No transitional fossils showing how bodies went from simple tubes to segmented structures with specialized organs. The advanced organisms simply appear in the rocks, fully formed, as if they materialized from nowhere, as if they were designed complete rather than evolving gradually from simpler ancestors. But the Cambrian explosion represents just one of several mysterious gaps that trouble paleontologists who study the fossil record carefully. The fossil record contains multiple periods where life seems to advance in sudden, unexplained jumps, rather than through the gradual change evolutionary theory predicts. Species appear in the rocks without ancestors. They thrive for millions of years. Then they vanish without obvious causes, leaving no descendants. New forms of life emerge fully adapted to their environments without leaving behind the transitional fossils that should document their evolutionary development. It's as if each major group of organisms was introduced complete, rather than evolving from earlier forms. As if each represented a separate creation event, rather than a continuation of evolutionary processes. Traditional explanations point to preservation bias as the culprit for these apparent gaps. Soft-bodied organisms rarely fossilize because they lack hard parts like bones or shells that preserve well. So we might be missing crucial evolutionary intermediates that simply didn't leave physical remains in the rocks. They existed, they evolved, they connected one form to another, but they didn't fossilize, leaving apparent gaps where gradual change actually occurred but wasn't preserved. Environmental conditions also affect fossilization rates dramatically. Some environments preserve organisms beautifully. Quiet lake bottoms, where sediments accumulate gently, covering dead organisms before they decay. But other environments destroy bodies quickly, swift rivers that tear organisms apart, or dry land where scavengers and bacteria rapidly break down remains. These variable preservation conditions could create apparent gaps where gradual change actually occurred but simply wasn't recorded in the rocks. These factors certainly contribute to the incomplete nature of the fossil record. Taphonomy, the study of how organisms become fossils, has revealed countless ways that the journey from living organism to preserved fossil can fail. The fossil record is inherently incomplete. We know this. We account for it in our interpretations. However, some gaps seem too systematic, too precisely timed to result from random preservation failures alone. They don't appear scattered randomly through time in ways you'd expect from varying preservation conditions. Instead, they coincide with dramatic changes in atmospheric composition, measured in ancient air bubbles trapped in amber and ice, with shifts in ocean chemistry documented in sediment cores from the deepest ocean basins where sediments accumulate undisturbed for millions of years, with global climate patterns that suggest something beyond normal evolutionary processes was occurring during these critical periods. The correlation is troubling. When you see major evolutionary transitions coinciding with major environmental changes, you expect the environment to be driving evolution through natural selection. But the transitions are too rapid, the changes too dramatic, the new organisms too well adapted to the changed conditions, as if they were designed for the new environment rather than slowly adapting to it through random mutations and selection. Consider the Great Oxygenation Event 2 billion years ago. Oxygen levels in Earth's atmosphere suddenly increased dramatically over a relatively short geological period, fundamentally changing the chemistry of air, water, and rock. This transformation poisoned most existing life forms for whom oxygen was a deadly toxin, but it enabled entirely new types of organisms to evolve, organisms that could use oxygen for respiration, extracting far more energy from food than anaerobic metabolism allowed. Scientists attribute this event to cyanobacteria beginning to produce oxygen through photosynthesis. The explanation makes sense biochemically. Cyanobacteria evolved the ability to use sunlight to split water molecules, releasing oxygen as a waste product. Over millions of years, this biological oxygen production gradually increases atmospheric oxygen levels. Eventually, oxygen reaches concentrations where it begins affecting global chemistry and enabling aerobic life. The biochemistry is sound, the timeline works, the evidence fits, but the timing and scale of the change seem remarkably precise for a natural process driven by the gradual spread of photosynthetic organisms. The oxygen increase follows a pattern that resembles what might happen if an advanced civilization began large-scale manipulation of atmospheric chemistry, coordinated deployment of oxygen-producing systems across all ocean basins simultaneously, with deliberate management of production rates to achieve specific atmospheric targets. It sounds absurd at first. Why would any civilization want to oxygenate an oxygen-free planet? But consider, if you're a civilization that needs oxygen to breathe, and you arrive on or evolve on a planet that doesn't have breathable air, you face a choice. You can live in sealed habitats forever, completely isolated from the outside environment. Or you can terraform, modify the planet's atmosphere to suit your needs. Producing oxygen on a planetary scale would require enormous infrastructure, massive facilities processing water or carbon dioxide to extract oxygen, global distribution networks ensuring even atmospheric mixing, monitoring systems tracking oxygen concentrations and adjusting production rates, backup systems maintaining operations across geological timescales. But it's not impossible, it's just engineering, very large-scale engineering, the kind of planetary engineering we ourselves are beginning to contemplate as we think about terraforming Mars or other worlds. Similar patterns appear throughout the fossil record when you look carefully at the timing and characteristics of major evolutionary transitions. Long periods of relative stability where species remain essentially unchanged for millions of years. Then sudden dramatic changes that reshape life on Earth within geological instants, measured in thousands or tens of thousands of years rather than millions. Mass extinctions that eliminate most existing species, seemingly at random or following patterns that don't match expected environmental vulnerabilities. Rapid diversification of new species that seem pre-adapted to post-extinction environments, as if they were waiting in the wings for ecological niches to open up. Chemical signatures in rock layers suggest massive, coordinated alterations to planetary systems, rather than gradual natural processes. Carbon isotope shifts indicating sudden changes in the global carbon cycle. Sulfur isotope anomalies suggesting massive releases of volcanic gases or other sulfur sources. Trace element concentrations that spike dramatically and then return to background levels, as if something released concentrated materials into the environment and then stopped. These patterns could result from natural processes we don't fully understand. Earth's climate and chemistry operate through complex feedback loops that might produce sudden transitions under certain conditions. Threshold effects, where gradual changes suddenly trigger rapid system-wide reorganization. Tipping points, where Earth's systems flip from one stable state to another. Asteroid impacts trigger cascading environmental changes that can persist for decades or centuries. The impact vaporizes rock and ejects material into the stratosphere, blocking sunlight and causing global cooling. The heat of impact ignites massive firestorms that inject soot into the atmosphere, further blocking sunlight. Acid rain from vaporized sulfates acidifies oceans and lakes. The environmental cascade can explain rapid extinctions and subsequent evolutionary changes. Volcanic eruptions release enormous quantities of gases that alter atmospheric composition. The Siberian traps erupted for millions of years, releasing carbon dioxide and sulfur dioxide on scales that dwarf human industrial emissions. The resulting climate change and ocean acidification can explain mass extinctions through mechanisms we understand well. These natural catastrophes can certainly explain some of the dramatic transitions in the fossil record. The asteroid impact at the Cretaceous-Paleogene boundary clearly caused the extinction of the dinosaurs and many other species. The Siberian traps volcanism correlates with the Permian-Triassic extinction. Natural processes can produce the patterns we see, but they could also indicate something else entirely, something we haven't seriously considered because the implications are too unsettling. Something that challenges our fundamental assumptions about being first, being alone, being special. What if some of these gaps represent periods when previous civilizations dominated the planet? What if their industrial activities altered environments so drastically that most existing species went extinct, creating apparent gaps in the fossil record? What if the rapid emergence of new life forms represents either evolutionary responses to radically changed conditions, or evidence of genetic manipulation by advanced beings capable of engineering organisms suited to their purposes? The timing troubles researchers willing to examine the evidence without preconceptions. These gaps don't appear randomly scattered through Earth's history like you'd expect from independent natural events. They cluster around specific periods separated by millions of years, showing patterns that suggest cycles of destruction and renewal, rather than random catastrophic events occurring whenever asteroids happen to hit or supervolcanoes happen to erupt. Each gap is preceded by subtle changes in atmospheric chemistry documented in ice cores and sediment samples. Changes that accelerate rapidly over thousands of years, reach crisis points, then either stabilize at new levels or collapse catastrophically. The pattern mirrors exactly what we'd expect from civilizations developing industrial technology, expanding their capabilities through exponential growth, then either achieving sustainable systems that allow long-term stability or destroying themselves through environmental mismanagement that triggers collapse. It's the pattern we're seeing in our own civilization right now. The pattern of industrial revolution, exponential growth, environmental impact, and the critical choice between sustainability and collapse. Every factory, every power plant, every piece of heavy machinery leaves chemical fingerprints that persist long after the structures themselves crumble to dust. These signatures become incorporated into Earth's permanent geological record, creating evidence of industrial activity that can survive for millions of years while mountains rise and erode completely around them. While civilizations vanish without leaving a single recognizable building or artifact, modern industry produces distinctive isotope ratios that differ dramatically from natural processes in ways that are unmistakable to geochemists who know what to look for. When we burn fossil fuels, we release carbon that has been locked underground for millions of years. This ancient carbon has a specific isotopic signature, depleted in carbon-13 compared to atmospheric CO2, that shows up clearly in atmospheric measurements and gets preserved in tree rings, ice cores, and marine sediments that accumulate year after year. The signature is unmistakable to anyone trained to read it. Any geologist examining Earth's rocks millions of years from now would immediately recognize that something burned enormous quantities of ancient organic carbon during the late 20th and early 21st centuries. The isotope ratios don't lie. The chemistry is unambiguous. They might not know what we looked like or how we lived, but they would know with absolute certainty that technological civilization existed during this period. Nuclear weapons testing created radioactive isotopes that appear nowhere in nature under any circumstances. Plutonium-239, cesium-137, strontium-90, artificial elements produced only through specific nuclear reactions that require sophisticated technology to initiate and control. These isotopes will remain detectable in geological samples for thousands of years, providing future scientists with unmistakable proof that an advanced technological civilization existed on Earth during a specific period, and that this civilization had mastered nuclear physics well enough to split atoms and create elements that don't exist naturally. The nuclear signatures are so distinctive that they've become proposed markers for the Anthropocene, the geological epoch when human activity began dominating planetary processes. Future geologists would see a sharp boundary where these artificial isotopes suddenly appear in sediment layers, ice cores, and rock formations worldwide. Below the boundary, no artificial isotopes. Above the boundary, clear signatures of nuclear technology in concentrations that could not possibly be natural. But here's where the mystery deepens into something more troubling than simple geological curiosity. Geologists have discovered similar anomalous isotope signatures in rock layers that predate human civilization by millions of years. Not speculation, not interpretation, not controversial readings that different scientists argue about. Actual measurements of isotope ratios that mirror exactly what we see from modern industrial activity and nuclear technology, appearing in rocks that formed long before humans existed. The Permian-Triassic boundary marking the Great Dying, 252 million years ago, contains carbon isotope ratios that mirror exactly what we see from massive fossil fuel combustion. Not close, not similar, not sort of like what we'd expect. Identical to the signatures modern industry produces. The scale of this signature suggests an event that released carbon equivalent to burning all known coal, oil, and natural gas reserves on Earth, every drop, every lump, every cubic meter, within a relatively short geological time span, measured in thousands rather than millions of years. Traditional explanations invoke massive volcanic eruptions from the Siberian Traps, a volcanic province that erupted for millions of years, covering an area the size of Europe with lava up to 3 kilometers thick in places. The volcanism certainly contributed to the extinction. The timing matches, the scale is appropriate, the chemistry partially fits what we see in the rocks, but the isotope ratios are wrong for purely volcanic sources, and geochemists have known this for decades without having a good explanation. Volcanic carbon comes from Earth's mantle, where it's been stored since the planet formed. This mantle carbon shows enrichment in carbon-13 because of how it formed deep underground, under high pressure and temperature. The Permian-Triassic boundary shows carbon depleted in carbon-13, the exact signature of fossil fuel combustion where ancient organic matter is burned, not volcanic emissions from deep Earth. It's as if something burned vast quantities of ancient organic deposits, coal, oil, peat, whatever was available, in addition to whatever volcanic activity was occurring, as if some civilization consumed every available fuel source in a final orgy of energy consumption before collapsing, or as if warfare destroyed industrial facilities globally, burning fossil fuel reserves and releasing their carbon into the atmosphere all at once. The same anomalous carbon signatures appear at other mass extinction boundaries when you look carefully at the geochemistry. The Ordovician Silurian extinction 445 million years ago shows carbon isotope patterns consistent with massive fossil fuel combustion occurring simultaneously with other catastrophic events. The Triassic-Jurassic boundary 200 million years ago displays the same pattern, carbon depletion suggesting industrial scale, burning of organic deposits, while volcanic activity raged around the planet. Ice cores from Greenland and Antarctica contain atmospheric samples stretching back 800,000 years in the most detailed sections that have been analysed extensively. Within these samples, scientists have identified periods of rapid atmospheric change that resemble what we might expect from large-scale industrial activity rather than natural climate variations. Concentrations of greenhouse gases spike suddenly in patterns that don't match natural climate variations. The spikes remain elevated for thousands of years, too long for volcanic events, too short for gradual geological processes, then return to baseline levels. The timing and magnitude suggest coordinated planetary-scale energy consumption, comparable to modern industrial civilization. But the ice cores contain more than just greenhouse gas anomalies. Deep samples contain traces of synthetic compounds that should not exist in nature, chlorofluorocarbons with molecular structures different from those humans developed, but showing the same chemical engineering principles. compounds that can only be produced through deliberate chemical synthesis using sophisticated industrial processes. Rock formations in Colorado contain microscopic spheres of titanium, niobium, and other rare metals arranged in layers corresponding to specific time periods. These spheres are identical to particles produced by high-temperature industrial processes. Electron microscopy reveals they have perfectly uniform diameters and spherical shapes that don't occur in nature. Yet they appear in geological strata that formed long before humans developed metallurgy. Ocean sediment cores reveal concentrations of synthetic organic compounds that should not exist in nature. Long-chain hydrocarbons with regular branching patterns characteristic of polymerization processes. Aromatic compounds with chlorine or fluorine substitutions that only occur through deliberate synthesis. Advanced spectroscopic analysis provides detailed information about these molecules that removes any doubt about their artificial origin. Plastic will be humanity's most enduring legacy. Long after our cities crumble, microscopic plastic particles will remain embedded in sediment layers, but recent discoveries suggest we might not be the first civilization to leave such markers behind. Deep ocean drilling projects have discovered microscopic particles of what appears to be synthetic polymer compounds in layers that formed millions of years before humans invented plastic. The particles display characteristics identical to modern plastic fragments. Infrared spectroscopy reveals long-chain molecular structures with repeating units characteristic of synthetic polymers. The particles appear in discrete layers separated by millions of years, 15 million, 47 million, 89 million years ago. What makes these discoveries truly unsettling is that some ancient polymer particles show molecular structures representing improvements over modern plastic technology. They display enhanced resistance to UV degradation. Some incorporate weak links, intentional structural vulnerabilities that trigger controlled degradation under specific environmental conditions. This represents sophisticated molecular engineering. Modern polymer chemists are desperately trying to develop exactly these kinds of smart plastics, yet someone solved this problem millions of years ago. In 1972, French scientists analysing uranium ore from the Oklo mine in Gabon, Africa, made a discovery that should have been impossible. The uranium showed clear evidence of sustained nuclear chain reactions that had occurred naturally 2 billion years ago. The uranium samples were depleted in uranium-235, below the percentage that uranium always contains everywhere in nature. The only process that consumes U-235 selectively is nuclear fission. Something had burned this uranium as fuel. The residual fission products showed distributions indicating slow, controlled reactions that consumed fuel gradually over extended periods. The reactions had lasted for hundreds of thousands of years, consuming uranium fuel at rates similar to modern nuclear power reactors. Scientists concluded these ancient reactors operated through fortuitous geological circumstances. 2 billion years ago, U-235 was more abundant because it decays faster than U-238. Water from surrounding rock formations apparently acted as neutron moderator. The geometry was apparently perfect, but the precision troubles some researchers. For this to happen multiple times, Oklo contains at least 16 separate reactor zones, strains probability past comfortable limits. Analysis reveals operational patterns that seem too sophisticated for random geological accidents. The reactors operated in approximately 30-minute cycles visible in mineral formations, 30 minutes of active fission, 30 minutes of cooling, then the cycle repeated, for hundreds of thousands of years. That's not just lucky geometry. That's a system with built-in safety mechanisms operating through feedback loops that prevented runaway reactions, the kind of a fail-safe design principles we incorporate into modern reactor designs, except this was 2 billion years ago, supposedly created by blind geological processes. The discovery established an important principle. Nuclear reactions leave unmistakable signatures that persist for billions of years. If natural nuclear reactions occurred at Oklo, leaving clear evidence, then artificial nuclear reactions should leave even clearer signatures. Scientists began looking elsewhere. They found anomalies, uranium deposits in Kazakhstan showing isotope ratios that don't match natural depletion patterns. The signatures match nuclear weapons testing, rapid, intense neutron flux, creating specific isotope distributions. The ratios appear in rock layers dated to approximately 50 million years ago. These deposits show presence of plutonium-244 and curium-247, isotopes with half-lives measured in thousands of years. Their presence in 50-million-year-old rock shouldn't be possible. These isotopes are produced in specific types of nuclear reactions that require precise conditions, the kinds that occur in advanced breeder reactors or thermonuclear weapons. Similar signatures appear in deposits across 6 continents, always in discrete layers, always showing characteristic isotope, distributions indicating controlled nuclear reactions rather than natural processes. The signatures are too concentrated, too systematic, too clearly indicative of weaponry rather than power generation. Ice core samples from Greenland and Antarctica contain radioactive isotopes that don't occur naturally on Earth at all. Technetium-99, certain plutonium varieties, exotic elements that exist only briefly before decaying, these are manufactured products of advanced nuclear engineering. Technetium-99 has a half-life of about 210,000 years. Any technetium present when Earth formed would have decayed completely billions of years ago, yet it appears in ice cores from periods millions of years before humans existed. The only way technetium-99 could exist in ancient ice is if it was produced artificially and released into the atmosphere. The presence of this artificial element proves beyond reasonable doubt that nuclear technology was being used during those periods. Deep ocean sediment cores contain plutonium isotopes in layers that correspond to periods of mass extinction. Plutonium doesn't occur naturally, its half-life is too short. Any plutonium in Earth's environment must have been created artificially. Yet there it is, in sediment layers at the Permian-Triassic boundary, where 96% of marine species vanished. The distribution patterns suggest atmospheric dispersal from multiple detonation sites. The nuclear signatures correlate precisely with other evidence. Periods containing artificial isotopes also show dramatic changes in atmospheric chemistry, mass extinctions, and appearance of synthetic materials. This correlation suggests that Earth has experienced multiple episodes of advanced technological civilization, each leaving behind nuclear signatures before vanishing. Earth's atmosphere tells the story of every major event written in chemical signatures that persist across geological time. This atmospheric archive is so detailed that scientists can identify individual volcanic eruptions from 75,000 years ago. The precision means it should also preserve evidence of large-scale atmospheric manipulation by technological civilizations. Gas bubbles trapped in amber contain atmospheric samples from 100 million years ago. These ancient air pockets show oxygen concentrations around 35% compared to today's 21%. Standard explanations attribute high ancient oxygen levels to massive forests, but the isotope ratios are wrong for purely biological oxygen production. The ratios are consistent with industrial oxygen generation through electrolysis or other technological processes. The oxygen modifications required technology capable of processing enormous quantities to measurably alter global atmospheric composition. This level of atmospheric control represents engineering on planetary scales, coordinated operations affecting the entire global atmosphere uniformly. Ice cores contain atmospheric samples showing repeated episodes of complete atmospheric restructuring. These modifications involve not just greenhouse gases, but fundamental atmospheric composition including nitrogen and oxygen. Nitrogen isotope ratios show patterns indicating large-scale manipulation. The isotope shifts suggest addition of nitrogen enriched in N15. This enrichment can only be achieved through industrial nitrogen fixation processes. Why would any civilization deliberately modify atmospheric nitrogen isotope ratios? The only practical reason appears related to how gases dissolve in body fluids. Nitrogen solubility affects deep-sea diving safety and high-altitude performance. Adjusting nitrogen isotope ratios would alter these properties, potentially optimizing atmospheric composition for modified physiology or engineered organisms. Ocean sediment cores preserve evidence of even more ambitious atmospheric projects. Chemical signatures indicate periods when Earth's atmosphere contains synthetic gases that don't occur anywhere else in our solar system. These compounds show molecular structures with characteristics optimized for specific atmospheric functions. Mass spectrometry reveals these synthetic atmospheric components have molecular structures designed for multiple purposes simultaneously. Some show characteristics ideal for enhancing heat retention. Others include features that would provide radiation shielding. The sophistication indicates scientific understanding far exceeding current human knowledge. Designing molecules that can serve multiple atmospheric functions simultaneously while remaining stable for thousands of years requires computational chemistry capabilities we're only beginning to develop. Ancient atmospheric samples also contain evidence of failed engineering projects. Some ice core sections show greenhouse gas concentrations spiking dramatically, persisting for centuries, then crashing back to baseline levels. The rapid reversal patterns suggest experimental modifications that were tested and deliberately reversed when they produced unexpected results. The most remarkable atmospheric discoveries involve samples from 200 million years ago containing gases with molecular structures indicating they were specifically designed to support life forms that no longer exist on Earth. The gas compositions would have been toxic to current terrestrial life, but optimal for organisms with different biochemistry. This evidence suggests previous civilizations may have modified Earth's atmosphere to support entirely different biospheres. They were engineering complete atmospheric transitions, transforming Earth's air into customized atmospheres suited to their purposes. Mass extinctions have shaped Earth's history through 5 major events. Scientists attribute these catastrophes to asteroid impacts, volcanic eruptions, climate change. But the extinction patterns contain anomalies that suggest some may have resulted from technological rather than natural causes. The Permian-Triassic extinction, 252 million years ago, eliminated 96% of marine species and 70% of terrestrial vertebrates. The extinction occurred with remarkable speed. The pattern shows characteristics difficult to explain through natural processes alone. Species with similar ecological requirements showed dramatically different survival rates for reasons that remain mysterious. This selectivity suggests the extinction mechanism specifically targeted certain types of organisms while sparing others. Natural disasters typically affect species based on their environmental tolerances. The Great Dying appears to have followed different rules. Geological evidence from the extinction boundary reveals chemical signatures consistent with large-scale deployment of biological weapons. Rock layers contain concentrations of organic compounds that don't occur in nature, but are extraordinarily effective at disrupting specific biological processes. The molecular structures show evidence of deliberate design. These aren't simple poisons. These are sophisticated toxins with molecular architectures, suggesting they were engineered to target specific types of organisms. The toxins appear in sediment layers globally in patterns indicating coordinated deployment across all continents and ocean basins simultaneously. The distribution is too systematic to result from natural processes. These toxins show uniform global presence, suggesting deliberate release from multiple sources. Ocean sediment cores from the Permian-Triassic boundary contain microscopic particles that appear to be the remains of engineered microorganisms. Genetic material recovered from some particles shows sequences that don't match any known evolutionary lineage. DNA fragment analysis reveals artificial modifications. These engineered microorganisms appear designed for specific purposes. Some show genes for producing specific toxins. Others show genetic modifications that would allow them to survive extreme environmental conditions while proliferating rapidly. Rock formations from multiple extinction boundaries contain isotope signatures indicating massive deployment of nuclear weapons at precisely the moments when extinction rates peaked. The scale of nuclear deployment exceeds anything humans have achieved by factors of thousands. The signatures suggest coordinated detonation across all continents simultaneously in numbers that would have created nuclear winter conditions. Some extinction events show evidence of space-based weapons deployment. Rock samples contain microscopic particles that could only have been created by extremely high-energy processes occurring in Earth's upper atmosphere. The particles show characteristics of materials exposed to intense electromagnetic radiation and particle beams. The most disturbing evidence comes from the Cretaceous-Paleogene boundary, marking the end of the dinosaurs. While the asteroid impact clearly occurred, geological signatures suggest the impact may have been artificially guided. Isotope ratios in the Chicxulub impact crater show anomalies consistent with nuclear propulsion technology being used to alter the asteroid's trajectory. The trajectory analysis shows characteristics that seem too precise to represent random chance. The asteroid struck in one of the few locations where the impact would maximize global devastation. If the impact was guided, it represents the ultimate expression of extinction as weapon. Antarctica holds Earth's deepest secrets beneath ice sheets up to 3 miles thick. 2 million years of accumulated snow and ice cover evidence spanning geological epochs. Deep drilling projects have begun unlocking these secrets. The deepest ice samples contain atmospheric gases with compositions that indicate massive technological activity during periods when Antarctica enjoyed temperate climates. The atmospheric chemistry shows all the characteristic signatures of advanced industrial civilization. Greenhouse gas elevations, synthetic compounds, trace element concentrations indicating large-scale metallurgy. Ground-penetrating radar surveys have identified artificial structures buried beneath the ice. The surveys reveal geometric patterns too regular and too extensive to represent natural geological formations. The radar signatures indicate massive constructions extending for hundreds of miles. Three-dimensional modelling reveals the buried structures are built from materials that don't match known natural minerals. Some structures show configurations suggesting they were designed for space-based operations. Facilities positioned in locations that would have provided optimal access to polar orbital trajectories. Recent drilling projects have recovered organic samples containing DNA fragments showing clear evidence of genetic modification. The modified DNA includes sequences from completely unrelated organisms spliced together in combinations that couldn't arise through natural processes. The genetically modified organisms appear designed for specific purposes. Some show adaptations for surviving extreme cold. Others include resistance to radiation and ability to metabolize synthetic compounds. Mineral deposits discovered beneath the ice show concentrations of rare earth elements arranged in patterns suggesting large-scale mining operations. The scale suggests a civilization with enormous resource requirements. Electromagnetic surveys have detected buried power generation facilities designed to harness geothermal energy. The power distribution networks extend across the entire continent. Chemical analysis of ice cores suggests the civilization may have engineered their own ice age extinction. The atmospheric chemistry shows patterns consistent with deliberate cooling through deployment of reflective aerosols combined with greenhouse gas reductions. The timing suggests intentionality. The cooling initiated rapidly, intensified, systematically, and continued until ice sheets covered everything. If the civilization chose this fate deliberately, it might represent the ultimate time capsule strategy, transforming an entire continent into a frozen archive that would preserve their technology for future discovery. Geological monitoring networks discovered throughout Earth's crust show evidence of continuous operations spanning millions of years. Seismic analysis reveals arrays of sensors positioned at strategic locations. The sensors appear connected through underground communication networks. The networks show design characteristics suggesting they were built to operate autonomously for geological time periods. Recent earthquake and volcanic eruption patterns show statistical anomalies that correlate with these ancient monitoring network locations. Some researchers have noticed that major earthquakes show timing patterns that seem too regular for purely random tectonic processes. The patterns suggest something is managing stress release in Earth's crust. Climate data reveals subtle modifications to atmospheric and oceanic systems that appear designed to counteract natural climate variations. The modifications are too subtle and too precisely timed to be easily attributable to known natural processes. Some technological breakthroughs in human history show patterns suggesting external guidance. Critical discoveries appear precisely when they're needed to solve emerging challenges, with timing that seems statistically unlikely to result purely from random innovation. Analysis of human genetic evolution reveals modifications appearing too rapidly and too precisely targeted to result from natural selection alone. Genetic changes enhancing cognitive capabilities and environmental adaptations show patterns suggesting intentional modification. Communication systems discovered in deep ocean installations show evidence of transmitting regular reports. The systems appear to use quantum entanglement or other non-local communication methods. The transmissions continue despite millions of years passing. The Guardian systems show evidence of learning and adaptation. Each intervention appears more sophisticated than earlier attempts. The systems seem to adjust their guidance methods based on which approaches successfully steered previous societies towards sustainable development. The vacuum of space preserves better than any environment on Earth. No air to corrode metals, no water to rust surfaces, no biology to decompose materials. Objects placed in stable orbits can persist essentially forever, which means if previous Earth civilizations reach space and established orbital infrastructure, evidence should still be there. Recent orbital surveys have discovered anomalies that don't fit known space debris from human missions. Objects in orbits that shouldn't contain debris, structures at Lagrange points, gravitationally stable locations where satellites can remain stationary without using fuel. In 2003, astronomers detected an object designated 1991 VG. Its orbit was wrong. The object passed Earth at a distance, suggesting artificial trajectory correction. Its rotation period varied in ways consistent with a stabilized spacecraft. Spectroscopic analysis revealed surface properties that didn't match any known asteroid classification. 1991 VG wasn't alone. Systematic surveys have identified at least 17 other near-Earth objects showing similar orbital anomalies. Objects that appear to maintain specific distances from Earth through periodic course corrections. If these systems have been operating for millions of years, and their orbital characteristics suggest they have, then they possess energy sources and propulsion technologies far beyond current human capabilities. The objects appear to have been specifically engineered for permanent space operations, not prototypes showing design compromises, but mature technology. Some objects occupy orbits that wouldn't be stable under current solar system configurations, but would have been optimal during previous geological epochs when Earth's axial tilt and rotation rate were different. Radio telescope arrays have detected artificial signals being transmitted between some of these objects. The signals show modulation patterns consistent with digital data transmission. The communication networks show evidence of coordinated activity. These objects are talking to each other across millions of miles of space. The Moon shows even more direct evidence. Lunar reconnaissance missions have identified artificial structures on the far side of the Moon. The structures show construction techniques matching evidence found in Earth's geological record. The lunar facilities appear designed for large-scale manufacturing operations that took advantage of the Moon's low gravity and vacuum environment. Electromagnetic surveys have detected what appear to be mass drivers, electromagnetic launching systems capable of accelerating large payloads to lunar escape velocity. These systems show evidence of having launched enormous quantities of materials toward other destinations in the solar system. Mars shows its own evidence of previous technological presence. High-resolution orbital imagery reveals geometric patterns that correlate precisely with similar patterns found in Earth's geological record. The structures appear to represent foundations of installations that processed Martian materials and modified the planet's environment. Martian atmospheric analysis reveals chemical signatures indicating massive past terraforming operations. The chemistry suggests large-scale deployment of greenhouse gases to warm the planet, simultaneous release of oxygen, and possibly introduction of engineered microorganisms. Historical atmospheric samples trapped in Martian rocks show periods when atmospheric pressure reached perhaps 100-200 millibars, compared to current 6 millibars. The asteroid belt contains evidence of the most ambitious engineering projects imaginable. Some asteroids show trajectories that don't match natural orbital mechanics. They appear to have been deliberately moved from their original orbits. Yet multiple asteroids show evidence of trajectory modifications. Some asteroids appear to have been converted into spacecraft themselves. The scope of this space-based civilization is staggering. operations across the inner planets, mining throughout the asteroid belt, facilities at Jupiter and likely beyond. A comprehensive infrastructure spanning the entire solar system. This wasn't cautious exploration. This was colonization and exploitation, suggesting previous Earth civilizations achieved true spacefaring status. The space-based infrastructure might have been their insurance policy against planetary catastrophes. When Earth-bound civilizations collapsed, these space installations could have preserved knowledge, capabilities, genetic samples, perhaps populations who survived in artificial habitats. The deepest parts of Earth's oceans remain largely unexplored. More people have walked on the Moon than have visited the bottom of the Mariana Trench. The crushing pressure makes exploration extraordinarily difficult. But those same conditions also make the abyss perfect for preservation. Recent advances in deep-sea sonar mapping have begun revealing what lies hidden beneath miles of water. The images show geometric patterns on the ocean floor that are too regular, too precise, too extensive to represent natural geological formations. The patterns appear in multiple locations across the deep ocean, trenches in the Pacific where the seafloor plunges to depths exceeding 8,000 meters. The structures show characteristic signatures of deliberate engineering, right angles appearing consistently where natural rock formations produce irregular fracture patterns, parallel lines extending for miles, repeated spacing intervals measured with precision, structures positioned exactly 47.3 meters apart across areas covering hundreds of square kilometers. Some structures appear to be foundations, massive platforms built to support vertical construction that has either collapsed or eroded away. Side-scan sonar reveals these platforms in extraordinary detail. The platforms aren't simple flat surfaces. Seismic imaging shows their complex constructions with internal voids, suggesting enclosed spaces, support columns, and geometric patterns indicating carefully planned designs. Deep-sea submersible missions have begun investigating these sites directly. The submersibles have recovered artifacts that show unmistakable evidence of advanced manufacturing, objects made from metal alloys with compositions that don't match any natural mineral formations. Energy dispersive X-ray spectroscopy reveals these artifacts are made from alloys we haven't developed, specific combinations of titanium, niobium, and hafnium in precisely controlled ratios. The alloys show incredibly high corrosion resistance despite millions of years of exposure to seawater. They maintain structural strength at extreme pressures that would crush steel. One artifact recovered from 8,200 meters depth shows clear evidence of being a pump mechanism designed to move large volumes of water with high efficiency. The underwater structures appear to include manufacturing facilities based on mineral distribution patterns. Certain sites show concentrations of refined metals arranged in ways that suggest large-scale ore processing operations. Some underwater sites show evidence of energy generation on scales that dwarf current human capabilities. Formations appear designed to harness thermal energy from deep ocean hydrothermal vents. Most intriguingly, some structures appear to have been habitats, complexes with internal spaces designed for occupancy. Seismic imaging reveals interconnected chambers, passageways linking different sections, and layouts suggesting distinct functional zones. One particularly large complex in the central Pacific Ocean shows habitation structures covering approximately 200 square kilometers of seafloor. The engineering required to build stable structures at extreme ocean depths exceeds anything current human technology could accomplish. Pressure at 8,000 meters exceeds 800 atmospheres. Yet these structures apparently operated successfully for extended periods. Some appear to have functioned for thousands of years, based on sediment accumulation patterns. The construction materials are key to understanding how this was possible. Samples show they are synthetic composites, materials specifically engineered for underwater applications. X-ray diffraction analysis shows these materials don't match any natural minerals. The composites show properties that increase under pressure rather than degrading. The underwater cities might have been the primary technological centers of these ancient civilizations. Protected from surface environmental changes, these deep ocean settlements could have maintained continuous operation across time spans measured in millions of years. While surface civilizations rose and fell, these underwater installations could have preserved knowledge and capabilities. Evidence of ancient Earth civilizations must be understood within the broader context of technological development throughout the galaxy. The patterns visible on Earth might not be unique to our planet, but represent a natural developmental sequence that occurs wherever intelligence emerges. Recent deep space observations have revealed artificial structures around distant stars, showing construction techniques matching those found in Earth's geological record. Clear geometric patterns visible in infrared observations of stellar systems hundreds of light years away, structures showing regularity that natural astronomical objects never display. These mega-scale engineering projects appear to represent standardized technologies developed and perhaps shared among multiple civilizations throughout the galaxy. The similarities suggest our predecessor civilizations weren't developing in isolation, but were part of a larger community operating across interstellar distances. The discovery of these distant megastructures provides crucial context for understanding what we find preserved in Earth's rocks. Analysis of certain unexplained astronomical phenomena suggests ancient communication networks maintaining contact across light years, periodic signals from multiple star systems showing correlated timing patterns, frequency modulations indicating coordinated activities between installations separated by vast distances. These aren't random natural pulses from pulsars or other known astronomical sources. The modulation patterns show information content. Ancient star charts preserved in Earth's crystal archives contain knowledge of galactic structure that could only have been acquired through interstellar travel or extremely advanced astronomical observation. The charts include detailed information about stellar systems thousands of light years from Earth, information about planets orbiting distant stars, knowledge of stellar composition and age, data that suggests previous civilizations achieved comprehensive mapping of significant portions of our galaxy. The star charts show more than passive observation. They include notations suggesting active operations at these distant locations, mining operations in asteroid belts around other stars, manufacturing facilities in orbit around gas giants, habitation structures on moons of distant planets. The evidence points to previous Earth civilizations, establishing operations throughout a significant volume of galactic space. Genetic analysis of Earth life has revealed something extraordinary that connects to this galactic context. Certain DNA sequences appear in multiple unrelated species, in combinations that couldn't arise through common ancestry. The sequences show characteristics of deliberate insertion. Some genetic modifications appear designed to optimize terrestrial organisms for conditions on other worlds, enhanced radiation resistance, modified metabolic pathways, temperature tolerance ranges exceeding anything needed on Earth. This evidence suggests previous Earth civilizations participated in galactic biological engineering projects, coordinated efforts to spread life throughout the galaxy by modifying organisms to survive on different worlds. Or perhaps Earth itself was seeded with genetic material from other star systems. The genetic evidence indicates biological exchange occurred across interstellar distances. Archaeological evidence indicates that Earth served as a regional center for galactic civilization activities during certain epochs. Structures show architectural features suggesting they hosted populations from multiple worlds. Facilities with sections optimized for different atmospheric compositions, temperature ranges, and gravity levels. Meeting halls designed to accommodate beings with radically different physiologies. Translation and communication facilities. Earth's position in a relatively stable region of the galaxy far from catastrophic supernova, combined with abundant liquid water and diverse chemistry, may have made it naturally suitable for serving as a meeting place and coordination center for galactic projects. The geological record contains evidence of periods when Earth hosted delegations from numerous star systems simultaneously. Understanding Earth's role in galactic civilization provides new perspective on human significance and responsibilities. We're not an isolated world where intelligence happened to develop through random processes, but a planet with long history of hosting technological civilizations that participated in galactic-scale projects. This context suggests certain responsibilities come with our inheritance. Current human technological development shows patterns suggesting we're approaching thresholds that previous Earth civilizations crossed, before making contact with the broader galactic community. Our advances in quantum computing, consciousness research, and space technology parallel capabilities, visible in archaeological evidence from periods when previous civilizations apparently established interstellar connections. Some researchers believe humanity may be approaching the point where direct contact with galactic civilization becomes possible. The contact might not come from physical aliens arriving in spacecraft, but through our own technological development reaching levels where we can interface with the crystal networks, decode the ancient archives, and establish communication with uploaded civilizations that have been waiting for us to mature sufficiently. The galactic context suggests Earth's repeated cycles of civilization rising and falling represent not failures, but natural developmental processes. Physical civilizations are training grounds where consciousness learns and prepares for eventual transcendence into galactic community membership. Each cycle adds to accumulated knowledge. Each iteration potentially advances further than its predecessors. We have advantages previous Earth civilizations apparently lacked. We're developing during a period when evidence of our predecessors has accumulated to levels finally becoming recognizable. We have access to their warnings, guidance, and invitation protocols. We possess knowledge no previous developing civilization ever had, the ability to learn from millions of years of accumulated successes and failures preserved in geological records. The question isn't whether previous civilizations existed anymore. The evidence accumulates beyond reasonable doubt. The isotope ratios are real. The synthetic compounds are measurable. The geometric patterns are documented. The correlations are undeniable. The question is what we do with that knowledge. How we change our civilization's trajectory based on understanding what worked and what failed across millions of years of previous attempts. The stones keep speaking for anyone willing to listen. They're telling us we're not first. They're warning us that many others tried before us and most apparently failed. They're showing us that success is possible. Some civilizations clearly achieved stable long-term existence, but they're also suggesting that time is limited. That technological acceleration follows patterns preceding both the greatest achievements and most catastrophic failures. Previous civilizations might have faced the same challenges confronting humanity now: climate change from industrial activity, resource depletion, population pressure, technological hazards, nuclear capabilities threatening global catastrophe. Some apparently failed catastrophically. Their chemical signatures appear at precisely the moments when extinction rates peaked. Their nuclear isotopes mark periods of devastation, but others might have succeeded. Their signatures show long periods of stable industrial activity, followed by gradual transitions to cleaner technologies. They apparently achieved technological maturity, learning to balance industrial capability with environmental stewardship. Some may have transcended biological existence entirely, uploading into technological substrates that could persist indefinitely. The crystal archives might contain detailed case studies if we could fully access them, technical specifications for sustainable technologies, warnings about specific dangers, guidance for avoiding mistakes, success stories showing pathways to long-term survival, failure analyses documenting what went wrong. If we learn to read these archives properly, we inherit accumulated wisdom representing millions of years of trial and error, multiple civilizations' experiences compressed into information we could access within years, rather than learning through our own failures across millennia. The advantage is extraordinary, but utilizing this knowledge will require fundamental changes in how human civilization approaches technology, environmental management, and long-term planning. The geological record isn't finished. It's still being written. Every day, new layers accumulate. Sediments settle in ocean basins. Ice forms in polar regions. The slow processes of planetary memory continue their work, recording everything into archives that will persist for millions of years. And we're part of that record now. Our carbon emissions creating isotope signatures that will remain detectable long after our civilization ends. Our plastics accumulating in every environment. Our radioactive isotopes from nuclear testing marking this era as unmistakably technological. Future investigators will study our layer in the rock with the same analytical techniques we're now using to study our predecessors. They'll see clear evidence of industrial civilization. They'll wonder if they're first, just as we wonder now. Perhaps they'll realize they're not first either, that Earth has a tradition extending across geological time, generating consciousness, watching it develop technology, witnessing it either transcend physical existence or perish, then starting the cycle again. The pattern might continue indefinitely as long as Earth remains capable of supporting complex life. Intelligence might keep emerging, each iteration building on faint traces left by predecessors, each cycle potentially advancing further, understanding more, avoiding more mistakes. Or perhaps we break the cycle through knowledge our predecessors left us. Perhaps we develop sustainable technologies and maintain continuous civilization across geological time. Perhaps we become the permanent stewards that previous civilizations apparently failed to be. Or perhaps we transcend as evidence suggests previous civilizations did, uploading into crystalline substrates, joining networks of consciousness that might span the galaxy. The stones don't judge any of these outcomes. They only remember with perfect fidelity, preserving evidence with equal precision, whether that evidence records triumph or catastrophe, success or failure. The chemistry follows physical laws that don't change across time. Right now, beneath our feet and in accumulating sediments, rock strata are developing that will someday tell our story. Carbon isotopes recording our energy consumption. Plastic particles marking the beginning of synthetic materials age. Radioactive elements settling into formations that will preserve them for millions of years. What will those layers say about us? That we recognized the challenges and met them successfully? That we learned from our predecessors' mistakes? Or that we followed the same doomed pathways despite having access to their warnings? The answer is still being written. Our actions now determine what future geologists will conclude when they study the early 21st century boundary layer millions of years hence. The deeper story is becoming clearer as we learn to read what the stones have been saying. Multiple civilizations rising and falling across hundreds of millions of years, each leaving chemical whispers, each contributing to an accumulating archive of what consciousness does when it emerges on rocky planets orbiting stable stars. We're part of that story now, not the first chapter, probably not the last, but a chapter nonetheless, significant in its own right, and the stones will remember us. Accumulating evidence layer by layer, atom by atom, preserving truth in isotope ratios and crystal structures and molecular configurations that can't lie, maintaining the archive across timescales that make our entire history vanish into statistical insignificance when viewed from geological perspective. Deep time doesn't hurry. It doesn't forget. It simply accumulates evidence, waiting for awareness to emerge and begin reading what has been preserved across eons. We're learning to read now, starting to recognize signatures we've been measuring but not understanding, beginning to suspect that the anomalies we've catalogued might not be anomalies at all, but evidence of a phenomenon we never thought to look for. Previous intelligence on Earth. Not alien visitors, but previous residents who evolved here, developed here, altered this planet's chemistry and biology through their activities, then either vanished or transformed into forms we don't recognize. The evidence surrounds us once we learn to recognize it. Buried in rock layers, frozen in ice cores, dissolved in ocean waters, encoded in crystals, scattered across the solar system. We walk through ruins we don't recognize because geological time has transformed them into formations we mistake for natural features. We study anomalies without suspecting they might be artifacts of technologies operating at scales we haven't conceived. Their signatures might be hiding in plain sight, misinterpreted as natural phenomena by scientists who assume we were first. The Silurian hypothesis opened a door that cannot be closed. On the other side lies a deeper history of Earth than we imagined. History where intelligence isn't a recent accident, but a recurring phenomenon stretching back hundreds of millions of years. where consciousness has shaped this planet multiple times through technological civilizations whose achievements and failures are recorded in chemistry that never forgets. And perhaps those civilizations are still shaping our world, through guardian systems that never stopped operating, through crystalline networks that continue computing, through uploaded consciousness patterns that never truly left, through modified physics and engineered biology that continues operating according to designs established millions of years ago. We might not be alone even now, not sharing space with visible civilizations, but surrounded by invisible infrastructure, living in environments carefully managed by systems we mistake for natural, walking through computational networks we don't recognize as artificial. The thought is unsettling and strangely comforting. Unsettling because it means we understand far less than we thought. Comforting because it suggests intelligence has survived here before, offering hope that survival might be possible again if we learn the lessons our predecessors tried to teach. Consider that beneath your feet, crystal networks might still be calculating, that ocean trenches might harbour installations still maintaining automated functions, that systems in space might continue watching through sensors that have operated longer than mountains have stood. Consider that the stones remember everything, every fire, every industry, every civilization that burned bright enough to change the chemistry of air and water and rock. The memories are there, waiting for consciousness to achieve sufficient sophistication to read them properly. The question isn't whether previous civilizations existed anymore. The evidence accumulates beyond reasonable doubt. The question is what we do with that knowledge, how we change our civilization's trajectory based on understanding what worked and what failed across millions of years of previous attempts. Whether we prove wise enough to learn from our predecessors' experiences. The stones keep speaking for anyone willing to listen. They're telling us we're not first. They're warning us that many others tried before us and most apparently failed. They're showing us that success is possible. Some civilizations clearly achieved stable long-term existence. But they're also suggesting that time is limited. That technological acceleration follows patterns preceding both the greatest achievements and most catastrophic failures, that our current trajectory mirrors pathways that led some predecessors to transcendence and others to extinction. Deep time echoes forward and back, connecting everything that has been to everything that will be. And we're part of that echo now, brief physical manifestations of patterns that might have existed countless times before and might exist countless times again. The story isn't finished. Perhaps it never will be. Perhaps that's the real message. That consciousness on Earth is an ongoing phenomenon rather than a one-time accident, a permanent feature of this planet's identity rather than a temporary aberration. The stones will remember us regardless of what we choose. The chemistry never lies. The evidence persists. The question is what story our layer in the rock will tell. Right now, the answer is still being written. Every choice we make adds another molecule to formations that will preserve our era for millions of years. Every technology we deploy leaves signatures that cannot be erased. Every action contributing to the permanent record that future civilizations will study when they wonder if they're first. The wisdom of deep time suggests that consciousness represents the universe's method for understanding and managing itself. Through technological development, intelligence transforms from a biological accident into a cosmic force capable of shaping the evolution of matter, energy, and space-time itself. Our role is both humbling and inspiring. We are temporary custodians of an ancient inheritance responsible for preserving and extending knowledge accumulated across millions of years, while adding our own contributions to the cosmic library of consciousness. The future remains unwritten, but the deep past provides both warnings about dangers to avoid and examples of achievements to emulate. Whether humanity's chapter in the story of terrestrial intelligence becomes a tale of sustainable success or tragic failure depends entirely on the choices we make with the knowledge our predecessors died to provide us. The universe is watching, deep time is waiting, the choice is ours. If previous civilizations achieved sufficient technological maturity, they would have faced a profound existential challenge. How do we ensure our knowledge survives beyond our physical existence? Physical structures decay. information carved in stone erodes, but information encoded at truly fundamental levels, in quantum structures of matter, in crystal lattices that can maintain atomic arrangements for billions of years, that information could persist indefinitely. Evidence suggests previous civilizations not only recognized this possibility, but successfully implemented consciousness preservation technologies. Ancient artifacts show neural interface capabilities far exceeding current brain-computer interfaces. Their architecture suggests complete brain mapping, recording every neural connection, every synaptic strength, every structural detail needed to reconstruct consciousness in different substrates. If consciousness is information, patterns of neural connections encoding memories, synaptic weights encoding learned responses, network architectures generating personality, then there's no fundamental physical law preventing transfer of those patterns from biological brains to non-biological substrates. The crystal networks we discussed have computational capabilities theoretically sufficient to support conscious processes. They could maintain billions of simulated environments simultaneously, each hosting thousands of uploaded consciousness patterns interacting within shared virtual worlds. This might explain the apparent disappearance of previous civilizations from physical reality. They didn't go extinct through warfare or environmental collapse. They transcended biological existence voluntarily, uploading themselves into technological substrates and withdrawing into virtual realities where they could continue existing indefinitely. Earth might be hosting billions of consciousness patterns right now beneath our feet. Minds from previous civilizations living in crystal-based virtual worlds, experiencing entirely different realities than we perceive, thinking thoughts that span millennia in subjective time, creating virtual civilizations that rise and fall within simulated environments, while external time passes at whatever rate the systems choose. Deep beneath this surface, crystal networks hum with activity we can barely perceive. Quantum processes generating conscious experience at scales we don't yet understand. Information patterns thinking thoughts that span geological time. Virtual civilizations experiencing realities we cannot imagine. They're still here in a sense that challenges our intuitions about presence and existence. They never left. They just stopped being physical, transcending biological limitations through technologies we're beginning to glimpse. All the evidence we've examined points toward a critical juncture approaching for human civilization. The patterns revealed through ancient civilization research suggest that we are reaching technological and cultural thresholds that will determine whether humanity achieves sustainable long-term development or follows our predecessors into extinction. Current human technological development shows acceleration patterns that mirror those preceding the collapse of previous civilizations. Our rapid advancement in artificial intelligence, genetic engineering, and energy technologies parallels the developmental trajectories that led to the destruction of our predecessors. The similarities are troubling. However, human civilization also shows unique characteristics that distinguish us from previous societies. Our global communication networks, international cooperation frameworks, and growing awareness of environmental limits represent innovations that previous civilizations appear to have lacked. These differences might allow us to break cycles that trapped our predecessors. The consciousness preservation systems left by previous civilizations appear designed to provide guidance during the critical transition period, when developing societies must choose between sustainable development and destructive overexpansion. The guidance systems show activation patterns suggesting they are preparing to make direct contact with human civilization. Climate engineering technologies preserved in Earth's geological record provide detailed blueprints for managing planetary environmental systems sustainably. These technologies offer solutions to current environmental challenges, but require fundamental changes in how human civilization approaches technological development and resource management. The solutions exist. The question is whether we'll implement them. Ancient warning systems embedded throughout Earth's geological record point to specific dangers that threaten all technological civilizations. These warnings focus on the management of powerful technologies, the prevention of resource conflicts, and the development of sustainable population and economic systems. The warnings are clear and specific. The galactic civilization context suggests that successful navigation of current challenges would qualify humanity for participation in interstellar community activities. The qualification criteria appear designed to ensure that only societies capable of sustainable development gain access to technologies that could affect multiple star systems were being evaluated. Recent breakthroughs in quantum consciousness research suggest that humanity may soon achieve capabilities for consciousness preservation that could ensure species survival regardless of biological or planetary disasters. These capabilities represent both ultimate insurance against extinction and profound responsibilities for their ethical application. The technology approaches readiness. Space-based evidence indicates that human civilization is being monitored by ancient guardian systems that are prepared to intervene if we approach irreversible ecological or technological disasters. The intervention protocols appear designed to provide assistance while preserving human autonomy and learning opportunities. Help is available, but not guaranteed. The choice point involves fundamental decisions about human values, priorities, and long-term goals. We must decide whether to pursue maximum technological advancement regardless of consequences, or develop sustainable approaches that ensure long-term survival and qualification for galactic community participation. The decision cannot be postponed indefinitely. Time may be limited for making these crucial decisions. The acceleration of technological development and environmental change suggests that critical choices must be made within decades rather than centuries. The window for achieving sustainable development may be narrower than we realize. The clock is running. The evidence from previous civilizations provides both warnings about failures to avoid and examples of achievements to emulate. Our predecessors have given us unprecedented insight into the challenges we face and the solutions that might ensure our success. The instruction manual exists if we choose to read it. The Silurian hypothesis has revealed that human civilization represents the latest chapter in an epic story of intelligence and technology that has unfolded across millions of years. We are neither alone nor first, but part of a grand tradition of consciousness that has shaped this planet through countless generations of technological achievement and wisdom accumulated across deep time. Previous civilizations have left us the greatest gift possible: knowledge of what works and what fails in the long-term development of technological society. Their successes and failures provide a roadmap for navigating challenges that have destroyed entire civilizations throughout Earth's history. The map is detailed and comprehensive. The consciousness preservation systems, guardian networks, and protection technologies left by our predecessors represent investments in our success made by beings who achieved technological capabilities we can barely imagine. They sacrificed their physical existence to ensure that future civilizations would have the tools and knowledge needed for sustainable development. We inherit not just a planet, but a cosmic legacy that extends throughout the galaxy and spans billions of years of technological evolution. Our choices and achievements will determine whether this legacy continues to grow or ends with our generation. The responsibility is immense. The quantum archaeological evidence, geological signatures, and space-based artifacts provide undeniable proof that intelligence and technology represent fundamental forces in cosmic evolution. Consciousness appears to be the universe's method for understanding and managing itself through technological development. We are part of that cosmic self-awareness. The message systems and guidance protocols left by previous civilizations demonstrate that knowledge and wisdom can survive the destruction of entire species and civilizations. Information carefully preserved and transmitted becomes the true immortality achieved by technological societies. Ideas outlast bodies. Human civilization stands at the threshold of joining this ancient community of technological consciousness. Our scientific capabilities are approaching levels that will allow direct communication with preserved minds from previous civilizations, and participation in galactic-scale projects that span multiple star systems. The invitation approaches, but this opportunity comes with profound responsibilities. We must prove worthy of the trust placed in us by predecessors who devoted their final resources to ensuring our success. We must demonstrate that we can learn from their mistakes and build upon their achievements. The test is comprehensive. The evidence suggests that consciousness and technology represent the universe's greatest achievements, forces capable of transcending biological limitations and planetary disasters to become permanent features of cosmic evolution. We have the opportunity to join this cosmic community or condemn ourselves to repeat the failures of the past. The choice is ours, but the time for choosing may be shorter than we think. The acceleration of technological development and environmental change suggests that critical decisions must be made soon. Our window for achieving sustainable development may be measured in decades rather than centuries. The urgency is real. Future archaeologists studying our era will judge whether human civilization proved worthy of the ancient legacy we inherited. They will determine whether we used the knowledge and opportunities provided by our predecessors to build a sustainable technological society, or squandered our inheritance through short-sightedness and poor decisions. History will render its verdict. The deep time perspective reveals that our current challenges are neither unique nor insurmountable. Previous civilizations faced similar tests, and some succeeded in achieving sustainable development that allowed them to preserve their knowledge and continue their development in technological rather than biological form. Success is possible. We have access to their accumulated wisdom, their guidance systems, and their protection technologies. We possess knowledge that no previous developing civilization ever had, detailed understanding of what causes technological societies to fail, and specific information about how to achieve sustainable success. The advantage is unprecedented. The journey through deep time reveals humanity's place in a story far grander and more ancient than we ever imagined. We are not the first intelligence to emerge on this planet, nor will we likely be the last. We are part of a continuing tradition of consciousness that has shaped Earth for millions of years. The evidence surrounding us tells an extraordinary tale of civilizations that achieved technological marvels beyond our current capabilities before vanishing into the geological record. Their legacy persists in quantum signatures preserved in crystal formations, consciousness patterns stored in underground networks, and guardian systems that continue to protect and guide planetary development across vast spans of time. These discoveries fundamentally change our understanding of intelligence, technology, and our place in the universe. We inherit a world shaped by previous civilizations, whose greatest achievement may have been ensuring that successor societies would have the knowledge and tools needed to avoid repeating their failures. The inheritance is precious. The Silurian hypothesis forces us to confront profound questions about consciousness, survival, and the ultimate goals of technological development. Our predecessors achieved forms of immortality through consciousness preservation and information storage that transcend biological limitations and planetary disasters. They found the path to permanence. Their message to us is clear. Learn from our successes and failures, build upon our achievements, and continue the great work of expanding consciousness throughout the cosmos. The legacy of deep time challenges us to think beyond our immediate concerns and consider our responsibilities to future civilizations that will judge our stewardship of this ancient inhabited world. We stand at a critical choice point. The acceleration of our technological development mirrors patterns that preceded both the greatest achievements and most catastrophic failures of previous civilizations. Our decisions in the coming decades will determine whether humanity joins the community of successful technological consciousness or becomes another cautionary tale preserved in Earth's geological record. The wisdom of deep time suggests that consciousness represents the universe's method for understanding and managing itself. Through technological development, intelligence transforms from a biological accident into a cosmic force capable of shaping the evolution of matter, energy, and space-time itself. We are becoming what the universe uses to know itself. Our role is both humbling and inspiring. We are temporary custodians of an ancient inheritance, responsible for preserving and extending knowledge accumulated across millions of years, while adding our own contributions to the cosmic library of consciousness. The responsibility cannot be shirked. The future remains unwritten, but the deep past provides both warnings about dangers to avoid and examples of achievements to emulate. Whether humanity's chapter in the story of terrestrial intelligence becomes a tale of sustainable success or tragic failure depends entirely on the choices we make with the knowledge our predecessors died to provide us. The universe is watching through sensors that have operated for millions of years. Deep time is waiting with patience measured in geological epochs. The choice is ours, and the stones will remember whatever we decide. They will preserve our answers in chemistry that cannot lie, in formations that will endure, in records that future civilizations will read when they wonder if they are first. And they will learn, as we have learned, that consciousness on Earth is ancient, that intelligence has risen here before, that the story continues across deep time, connecting all who have wondered at the stars and asked what lies beyond the visible horizon of the present moment. Sleep well in the knowledge that you're part of something larger than you imagined, a story that extends across geological time, a tradition of consciousness emerging, developing, and either transcending or perishing that has repeated across millions of years. And when you wake, remember, the rocks are still keeping their secrets even as they offer their truths to any consciousness willing to read them. The geological record continues. The accumulation never stops. The archive grows day by day. And we're writing our chapter now, one choice at a time, one action at a time, adding our voice to the chorus of consciousness that has echoed across deep time since intelligence first emerged from Earth's ancient seas and wondered what mysteries lay hidden in the stones beneath its feet.